I will just put this water, then we will later on we can go to import the water body.
Same case has also have the water.
Yeah, it's really pretty. Okay. Okay. So the first part is like to have the 3D CAD body.
Loading the part.
No, fine. Yeah, first we have to load the part. So there are many ways to do that. First one is you can always create a part from here. This is the create part menu.
Okay.
So we can create the part. The other way is you can click here, right click and import.
Okay.
Yeah.
But let me have a note. First one. Create a part. Okay. Or
Yeah.
import.
Import.
Okay.
When you click on the import, okay, let him come. I already have my folder in which I have Sam's file.
Yeah.
So you can use my folder, the same folder, if you want.
We will have a new one.
Yeah, no problem. It's all the same.
Folder is free.
Yeah, it's free. No, I mean I don't want anyone to delete it unnecessarily
Yeah.
because I'm not sure who used the computer. Sometimes the file is gone. That's why I keep it in my folder. Anyways, no problem. We need the IGES file. When you export the file from Fusion 360,
Fusion.
yeah, you can either have an STEP file or IGES file.
Okay, IGES file.
The STEP file is the solid file format.
Yeah.
IGES is the surface based. I always prefer IGES because we are using the library structure.
IGES.
IGES file.
Okay.
So I will import the structure. So in this I have named the structure impact sample. This
Okay.
one. So let me just
So
import
you
this.
usually have two files. One is step and the other is
IGES.
IGES.
You can import many different files. It's just one type. Oh, Sam, when you imported, where did you keep the design? Is the same folder or different folder?
The name.
The new
one.
design, yeah.
Oh.
It's a different folder,
oh.
right? Yeah. So when I import, there is a problem.
Remove your
So now we import the file.
Okay. So didn't have changed any setting.
Nothing,
when you
yeah.
Okay.
So this is our file, the sample.
Okay. We got us.
Okay. Got the sample. Now we need to get the punch, the impactor.
Impactor.
Yeah, so I've already made the design for that, the impactor here.
Okay.
I will just load the impactor. This is the impactor punch. Yeah, I know.
Very funny.
Yeah, I told Sam the same. Not only little bit. When you put color, it becomes Sam's rainbow dig.
Yeah. Seems really like rainbow dig.
Yeah. So, and another thing is, now we have the sample. We need a base
Yeah.
to keep the sample on the top.
Yeah.
So we need to make the base here. So the way I told you, you need to go to create the part.
Great.
You click on the create part, and then we have many different kinds of system here. We have 3D, 2D, axisymmetric, and then in the type we have deformable, discrete, analytical, Eulerian. So these are the kind of file format we can make.
Yeah.
Now this structure is actually 3D deformable because it will undergo the load, so
Okay.
it will deform. But the base we don't want it to deform.
Yeah.
So either we can go on the discrete rigid or we can
Rigid.
go to analytical rigid.
Rigid.
With the discrete rigid, you have to make a mesh. Even if you have the flat plate, you need to make the mesh.
Yeah.
But we don't want that hassle also,
Yeah,
so we
yeah.
just go for analytical rigid. So you don't need to make any mesh or something.
Okay.
I press on continue.
Plate.
So I press on continue, we get this grid. I need to update this. Or later. No. So here we will make, did I select revolve shell, right? Okay. I will make this as base. Click. And then now I will make just a line segment because I select the revolve function.
Yeah.
So I will just make a line, it will revolve around the axis, the z axis. So
So you will set the center of the
Yeah.
impact head on
no, this is the plate on which the sample is kept.
the. Okay.
So our sample, in this case, sample dimension is 60, right? 60. So we just take around 40, right? So we have the circle of 80 millimeter diameter.
Oh, you have to circle an area that.
Yeah. So I just make a line. Now once I press done, it will become a circle.
Okay.
Because it will.
Where did you press the line?
There was a done option here. Let me
Oh.
delete this and
Okay.
make this again.
Sorry.
No problem. Let's see. I create. I will just write here as the base. Okay. This is analytical rigid, and then I have there are two things: extrude shell and revolve shell. If I place extrude and make a line, it will extrude in this way.
Okay. So
Like a
it's
rectangle.
revolve shell.
Yeah. So because in our experiment it is circle with the bottom, so I will just take the revolve shell.
Okay.
Press OK. The size you can keep anything from 2000 to 120 because it depends on the grid size.
Yeah.
If I press 200, it's like the
Yeah, but you
number
only
of
circle the part of it. Then.
yeah. So I just make one line so that it becomes. I come to the center here and go around maybe 40 because that will be an 80 centimeter circle. Then I press done here.
Okay.
You get a circle like this. Now, if I have to give a boundary condition to this,
Yeah.
I need a reference point. Otherwise, I cannot give a boundary condition to this.
Yeah.
So for that, I will go to the tools.
True.
There's a reference point.
Okay. True.
Reference point. Once you select that, you see there are yellow dots appearing here. So you select the center part, yellow dot. Make it. You see RP.
Okay. Reference point.
Reference point. Because why we create reference point is because when we need to extract the data, we need to select from which point you need the data. We won't select full surface.
Yeah. You
Just
you
want
need
one
to,
data.
Observe
Yeah.
the origin reference points.
Mhm.
Maybe it's dense. Then after the impact, you will got it dense.
Yes. So now once we select this, we can put any boundary condition on this one. If you want to fix, we put the fixed condition. The whole plate is fixed.
Okay.
You just need one point. That's why reference point is important. Then we import all the parts, right?
Yeah.
Another important part is because the software does not know which is the surface. Let's say I have this impact sample. Now it has to impact, so it will impact on this surface on the top,
Yeah.
and there is another surface at the bottom,
Yeah.
right? So I need to define that this is a surface. Otherwise, it will not recognize this as a surface.
Yeah.
So let's make this as a surface. We go to not this one, the impact sample,
Impact
surfaces.
Okay.
Double click, open the surface. I just write top surface. If you write like this, it's
还有
very
很多
long.
的现在第一个是第一部分是
Yeah,
part，
and
然后第二部分是
Just make any like TS,
那
right?
你
Just
怕结
TS.
束之后，你可以先
Yeah.
卡一段，
嗯
然后再留一段新的这样。
Yeah. And I press OK. Now I get an option to select the surface. So I will just select this one. You can see on the when I select on the top,
Yeah.
I should not see like that. I should just see this.
The
So this is
whole
top.
clear,
Yeah,
the
clear.
clear top.
And I press done.
Yeah.
So now I have,
Hopefully-
when I select this, you see.
Yeah, hopefully we got all our sample have a top and a bottom,
Yeah.
so it's more easier.
So now I create another one to make the bottom.
Buttons and
And like this. Yeah. Bottom surface. So both our surfaces are defined. Okay. But we also want the center point here because we want to load it at the center point.
yeah,
But we can see that there's no geometrical point
Yeah,
to
yeah.
see the center. So what we do is we create a partition here.
okay,
So let's see how we can do that. Go to here option. There is a Caesar.
okay.
There's a Caesar.
Create partition.
Yeah. So we just click on the create partition. Then we have the edge, face, and the cell.
Okay,
So we want to partition the face,
okay,
and we will select use the shortest path between 2 points. You can select many other. If you have a datum plane, you can select a datum plane, but we don't have anything. We just select the 2 points.
okay.
And press done. So like this. Again, select the surface and
Yeah.
done. So now you see there are yellow dots everywhere.
Okay, use the shortest path between 2 points.
We haven't selected the 2 point yet. You see it says select a start point. So let me just select the start point. One is this because this is the center.
Yeah,
One should be here.
yeah.
Okay. Click on create partition. It will separate the two surfaces.
Yeah.
Okay. Now I want the center, so I will just partition these two. Then I can get the center. Correct?
Wait. Okay.
Okay. So now we separated the two. Then we have to half this also. So I just select this again. Select the surface. Done. Select the point.
Oh, you got the center point.
Yeah, I got the center point. I will cut this also so that the mesh quality is good. So let's select again, surface, done, the center point here, point there, and we're done.
Oh, do you have to measure?
Later we'll do the mesh, so you will see the top surface mesh is much better. You see this one,
Okay.
the top surface, because this is the
Because
center.
it
Center.
It creates four partitions.
Yeah. So you see, yeah, the mesh quality here is much better.
Yeah.
So that's why it's better to keep symmetry. Symmetry is always good. Go back to part. Do the same operation at the bottom surface. Done.
Yeah. That's good.
Good to go.
Good to go.
Okay.
Okay.
So now this is done.
Yeah.
Now we need to put the property.